This is going to be the third video about inverse functions, and in this video I want to talk about drawing the graphs of inverse functions. So let's start with this graph of a simple linear function. Here I've got the function y equals 2x minus 2, and I've drawn the graph. Now, to find the inverse of this function, we can do something really pretty simple. Let's take a look at these 2 points where I've got the vertical intercept and the horizontal intercept. Okay, so at the vertical intercept, I can write the ordered pair 0, negative 2. And at the horizontal intercept, I can write the ordered pair 1, 0. And remember, in an ordered pair, the first number is the independent variable value, or the x value. The second number is the y value, or the value for the dependent variable. Now let's think about it. If I'm going to do the inverse function, the graph of the inverse function, then what it means is I'm going to be swapping my x and my y values. So if I've got a point 0, negative 2 for my original function, that means in my inverse I'm going to have the point negative 2, 0. Which would be right here. I'll put that in red. Negative 2, 0. And if I've got this point on the horizontal axis, y, 0, then on the vertical axis I'm going to have the inverse of that point, or 0, 1. So 0, 1 would be right here. And now, since this was a linear function, which is a straight line, I can just take a ruler and connect those 2 points, and I'll get the graph of the inverse of that function. Okay, so the black line is the original function, and the red line is the inverse. Okay, and that's all there is to a simple linear function. Now, let's take a look at something a little more complicated. Here I've got a function that is just kind of a jagged line, and I want to draw the inverse graph for this function. So let's see. I'm given these points on the graph. I've got a point negative 3, negative 2. That means my inverse is going to have the point negative 2, negative 3. So let's see where that is. Negative 2 is over here, and negative 3 is down here. So I'm going to have this point here at negative 2, negative 3. All I did was take one ordered pair and reverse the numbers. I found the inverse for that ordered pair. Then I've got this ordered pair negative 2, 0, which means I want 0, negative 2. That's right here on my vertical axis, 0, negative 2. I can connect those 2 lines. And now going on, I've got this point here in the original function 0, 1. So I want 1, 0. That's going to be right here on the horizontal axis. So I'll connect this line further. And then I go up to 2, 3, which means I want 3, 2. So here's 3 and 2. So I'll go off like this. Okay, so the black line, once again, is the original function, and the red line is the inverse of that function. Now, in general, this is a pretty sloppy graph, but if you draw a line where you have y equals x, which is just a diagonal line, what you're going to find is that an inverse function is basically what you would get if you flipped your original function along that dotted line. If I were to fold this piece of paper in half along that dotted line, the black original graph should touch the red inverse line, assuming I drew it nicely, which this isn't really a great graph. Okay, now let's look at one more function. You remember in a previous video we talked about the horizontal line test, and we had this parabola, y equals x squared. And we saw that that parabola failed the horizontal line test. Let's take a look what would happen if we tried to graph it anyway. So since it's y equals x squared, when x is 1, well, x squared is 1, so I'm going to have a point 1, 1. And when x is negative 1, x squared will also be 1, so I'm going to have negative 1, 1. And then when x is 2, well, 2 squared is 4, so I'm going to be up here at 2, 4. And when x is negative 2, I'm also up at 4. I've got negative 2, 4. Okay, so let's see what happens if we want to take the inverses for those points. So, oh, and I've also got a point 0, 0, since the graph goes right through the origin. So I know I'm going to have a point here on my new graph. And if I invert this 1, 1, I still get a 1, 1. If I invert 2, 4, I get 4, 2. So let's see, that would be out about here somewhere. So I can draw the inverse of this curve here would look something like this. But then when I go to draw the other half of the graph, I've got negative 1, 1. So the inverse of that would be 1, negative 1. And I've got negative 2, 4. So the inverse of that would be 4, negative 2. So let's see, 4 is here. Negative 2 would be around here. 4, negative 2. And when I connect those dots, well, what I've done, if I draw this diagonal line, what I've done is kind of like the equivalent of flipping this original parabola across that diagonal line, but now you can see that it fails the vertical line test. So the inverse is failing the vertical line test because the original failed the horizontal line test. Okay, take a look and think about the relationship between these two graphs and the idea of a horizontal line test for the black graph and a vertical line test for the red graph. And you can see why if you fail the horizontal line test for your original graph, your inverse graph will not be a function because it will fail the vertical line test. Okay? But basically, assuming you've got a graph which is a function which is 1 to 1, which you can invert and get another function, all you're going to do is you're going to take the points on the graph, take any points on the graph that you know, take the inverse of those points. In other words, take the ordered pair and swap the numbers around. And then plot those new ordered pairs, connect your dots, and you'll have a graph of the inverse. Okay? So that's it for now. Take care. I'll see you next time.